EF Core recently added bulk updates, which allow you to significantly improve the performance of your update and delete queries. However, bulk updates come with an important caveat that you must know if you want to use this feature. Here's a quick introduction into the EF Core bulk update features and what you need to know before we dive into the caveats. The bulk update feature is exposed through two new APIs, the ExecuteUpdate, which also has a respective async overload called ExecuteUpdate async, and the ExecuteDelete and ExecuteDelete async methods. Both of these were added in EF Core 7 and they were improved as part of EF Core 8. This is what a bulk update query looks like. You can use your database context to select a database set. In this example, the products database set, which is going to match the respective table in the database. Then you can write a where statement to filter out any products that you want to update. And finally, you will call the ExecuteUpdate method where you can specify which property you want to update. Now, the important part is that you need to know what is the updated value before you execute the query, so that EF Core is able to apply this update in the database. The ExecuteDelete method works much the same. You would write a link query to select the records that you want to update, and then you call ExecuteDelete, which is going to issue a delete statement and remove these records from the database. So what was the motivation for adding these new APIs? Because we can already do something similar with existing EF Core functionalities. Well, the answer to this question is performance, because these new APIs are more efficient when updating or deleting a large set of data. If we take a look at the previous query, which was executing the ExecuteUpdate method, this is the SQL that would be generated. Here is the SQL that EF Core is going to generate when sending this query to the database. You can see that this is just one update statement setting the price of the product in the products table and also filtering based on the category. If you wanted to do this with the traditional EF Core approach, you would have to first load all of these products into memory, update their price, and then call SaveChanges, which would update these values to the correct values. However, that would execute many update statements on the database instead of just one with ExecuteUpdate. And the same applies for ExecuteDelete. It's just going to generate one delete statement instead of many delete statements with the traditional EF Core approach. The takeaway is that the EF Core bulk update APIs have fewer round trips to the database and are therefore more efficient. Now let's head over into the code, where I want to show you a big problem that you could run into with the bulk update features. The first thing I want to focus on is how the EF Core ChangeTracker works. So let's say I use my database context to select one product record from the database. Now I'm going to look for a product record with the ID equal to 1. And then let's go ahead and update the price of this product to 99.99. When we update this value, assuming it's different from the original one, EF Core is going to pick up on this change, and when we call context SaveChanges or SaveChanges async, it's going to update the respective value in the database. Let's say I want to use the async APIs, and then let's do another change where I want to introduce a new product. So let me create a new product instance. I'm going to set the name of this product to some new gadget. And then let's set the price to 129.99. When I say context products add new product, EF Core will start tracking this product as part of the change tracker. Finally, when we call SaveChanges, this is going to cause one update statement and one insert statement to be sent to the database. So let's start this application and just briefly take a look at this. So now I'm in debug mode. I'm going to fetch the product from the database, update the product price, and then let's add a new product with the respective name and price. And when we call SaveChanges async, this is going to send the respective queries to the database. If I open up the console here, we can take a look at the queries that are being sent to the database. So here is the update statement to set the new product price for a specific product with the specified identifier. And then we have an insert statement to introduce a new product into the database with the respective values. So you can see how EF Core translates our changes on the entities into SQL queries. And now let's go ahead and call one of the bulk update methods. So I'll say context products, and let's filter out any products where the category is equal to electronics. And then I can call the ExecuteUpdate async method. Now this method allows me to set some specific property on the product instance. We have to specify a function that's going to execute the actual update, and we just call the setProperty method to set the property value to some updated value. So the first argument here is to actually select the property that I want to update. So let's say I'm updating the price, and then I need to set what is the updated value that's going to be applied to this property. So we can use the existing value if we want to. So let's say I want to take the original price by 0.01. You can also apply multiple updates by chaining additional calls to the setProperty method. So let's say after updating the price, I can go ahead and update any of the other properties. For example, I could update the description to whatever is the old description plus some new value. So I could say new and then specify the original description. And this would update all of the products matching this where statement. But for now, let's just update the price. So let's check out how the execution looks this time with the ExecuteUpdate method. We're going to load the product, update the price. We're going to introduce a new product into the database. And then this call here is important. If I take a look at the product that I loaded from the database, you will see that the category is electronics. The price of this product is $99.99, which we set in memory. So we could expect that when we execute this bulk update, it's going to also increase the price of this product that we have in memory by 0.01. So let's see if this is the case. I'm going to execute this execute update statement. And if I take a look at the product, you will see that the price remains unchanged. This is because the execute update method immediately goes to the database. You can also confirm this if you take a look at our console, and if we navigate down, we should see an update statement that was ran from the execute update method. So here it is. It's update, set the price of the product to the existing price plus 0.01, and you can see the where statement here that's checking if the category is electronics. So this is a very important thing to know when using bulk updates. The execute update and execute delete methods immediately go to the database. This means they run outside of the context of the change tracker, which is going to execute when I call SaveChanges async, and this would send additional queries to the database, which you can see here. So here is the update statement and then an insert statement. So we have two separate transactions, one that is implicitly managed by the change tracker, and then another one from the execute update method. Everything I just mentioned also applies to execute delete. Now, why is this a problem? Well, first of all, if you rely on any changes being applied by execute update to be reflected on your database entities that are in memory, for example, you want to use these values in a calculation after executing the execute update, then you have a problem. You will be out of sync from the state. Your state in memory and your state in the database are going to be out of sync. Now, a second and more important problem is that if you encounter an exception after you run the call to execute update, the call to save changes will not complete. However, the execute update method will already have been applied to the database, so you risk ending up in an inconsistent state. So how do we solve this? The simplest approach is to introduce a try-catch statement. So let's say I want to catch any exception, and let's bring back the code that we had previously. Now I'm also going to do one more thing, and that is to open up a new transaction. You can do that by accessing the database context and the database facade, and then you can say begin transaction or begin transaction async. Now, what this is going to allow you to do is to open up a transaction before executing any changes on the database. And because execute update is going to use this database context instance, it's also going to be part of the same transaction, which means that in case of an exception, I can run a rollback statement, and this is going to revert any changes that were inadvertently applied by execute update. Otherwise, if all of our changes complete, we're going to call transaction commit, and this would persist all of our changes together. So what we want to do is to have the execute update changes and the database context changes be applied as the same transaction. One note about rolling back the transaction is that you don't have to do it. You could also just let the transaction go out of scope, and if commit is not called, rollback is going to be called automatically. But let's go ahead and demonstrate this for the sake of completeness. So let me go ahead and run this. So we're going to update the product, introduce a new product, and then we will call execute update. So this is going to apply the changes in the database. However, because they are part of a transaction that isn't committed yet, other transactions will not be able to see this. Now we are going to throw an exception intentionally, and we are going to roll back the transaction, which is going to revert any changes that were applied by execute update. And as I said already, all of this applies just the same to the execute delete method. So if you want to keep your database in sync and you want to use ExecuteUpdate or ExecuteDelete together with EF Core, you have to execute this inside of the same transaction. Now, when it comes to performance, let's go ahead and verify if bulk update is as fast as we expect it to be by running a simple benchmark. So I'm going to execute the bulk update benchmark, and if I head over to the benchmark class, you can see I have two benchmarks. One is doing the standard update, which is just fetching some products from the database. I'm taking just the first 10 products with the specified product ID, increasing the price by some simple amount, and then calling SaveChanges. In the bulk update benchmark, we're just going to call the ExecuteUpdate async method once, and this is going to apply the same updates. So let's go ahead and run these benchmarks and then observe the results. So we have our results, and you can see that the bulk update approach with the ExecuteUpdate method is practically twice as fast as the standard approach with loading the values into memory, updating them, and then calling SaveChanges. And this is to be expected because the bulk update approach is only sending one query to the database, whereas the standard approach is going to send one update statement for every entity that we load into memory. So if you care about performance, you should definitely take a look at the bulk update APIs, which are exposed for the ExecuteUpdate and ExecuteDelete methods. However, be mindful that they run outside of the ChangeTracker, which means you would have to run them inside of a transaction to make them work together with the EF Core ChangeTracker. And I'm also highlighting that these APIs do not trigger EF Core interceptors, which is another important thing to know. If you want to learn more about optimizing EF Core performance, then you should watch this video next. Also, check out my clean architecture and modular monolith courses. Thanks a lot for watching, and until next time, stay awesome.